Alright, okay, so we're making, for the first video, a goddamn linear regression model. And, yes, let's go. Whatever I have, let's just delete this shit. Very good. Go. Very good. Now we gotta first import numpy. Okay, this thing. Then import matplotlib.pplot as plt. Then what else? Okay, whatever. I forgot about everything else. So we have to then declare a variable which is x, and within x we'll just have few data points. Beautiful. 3 data points for now. We don't really have to do anything else. Okay, later we can have more data points, or just have a CSV file if you want to. And for CSV file, I think we have to import Panda. For now we don't really have to use Panda because we are not importing a CSV file. Okay, and CSV files is nothing but it's sort of like a comma separated value. So like comma separated value could just be like 1 2 3 4, and like this is a row and this is a column, this is a row and this is a column. 1 2 is a row, 1 3 is a column. Okay, looks like a matrix, but it could be in any shape or form. Okay, so for now we're not using a CSV file, so we could just do anything we want. 3 4 5, that is the value of x and y. Okay, so for now we could go for the next step where we have to find the excuse me. Yes, so we have to find the mean of 1 2 and 3, and essentially the mean of this data, right? So what's the mean of the data? We have to sum this particular data, and we have to get we have to divide this by 3 because the number of elements inside the x variable, x list is 3. Okay, so we are supposed to do that. I'll just write that down quickly. Okay, x bar equals for this one we're supposed to sum. So sum is nothing but you just put sum and put a bracket in. So we just use the variable x for this in this case because we are having x bar, not y bar, for y bar. So yeah, the next thing we just divide this thing by len of x. What does len mean? Len means length of the variable. So we just put the variable inside the bracket and we're getting the variable here. Yes, and this is the capital X. So capital X doesn't mean, okay, now we are having the x bar. Okay, so x bar is inside this particular variable, which is known as x bar. Okay, so the mean of this particular data is x bar. So for now we'll just have the y bar. Sorry, we'll next go for y bar. Okay, for God's sake, I'll write it. Wait. Bar equals sum y len y. Yes, great. So we got the second mean of the data as well, which is this y coordinate here. Okay, so now next thing what we do here is we got this thing and this thing. Now we got to calculate the numerator and the denominator. Numerator and denominator of this particular function. M equals I'll just tell you. Then we get the numerator of a you have to find the slope of the thing. Yeah, I'm so confused. Okay, we have to find the slope of the thing. I'm pretty sure you have seen this particular form somewhere, right? Y equals mx plus c. I'm pretty sure that you have seen this particular form, right? So y variable is just the y here, y coordinates here, and x variable is the x coordinates here, and m is the slope of the particular equation, right? And c is the C is what? C is what? C is what? C is what? C is the constant or y-intercept. Yes. So that's about it. We're supposed to do a few more coding here. How do we do that? We are supposed to yes, find the m. So m, if you try to calculate that, we are supposed to get some numerator divided by some denominator. There is a particular formula which I'll be writing, so we'll just write the numerator of the formula. So the numerator essentially is, we'll just keep it empty for now, sorry, 0 for now. The denominator will keep it 0 as well. Then we'll use a for loop, for an I in range. You could just use for, I guess, 0, 4. No, that's not how you write it. For God's sake, wait a second. Essentially, we are trying to get the range here, so we can just write the starting value as 0 and ending value as this element plus 1. Okay, this element plus 1. So 1, 2, 3. There are 3 elements, so we could just write plus 1 essentially, or 4 here, and we could just write this particular thing. Can you see this shit? This thing? Okay, like this 2 dots here. Okay, I think they're called semicolons. So after that, you're supposed to write the n num plus or equal. So there, so we're adding it, and we are Ew, I don't think we are adding it. We are multiplying it, maybe. Are we multiplying it? I think we are adding it. We're adding it. Yes. So we are adding it. You're adding this term. I'll just write it quickly. I minus x bar multiplied by y bar, and denominator as x I, then x underscore bar, and we'll just give it power to 2. Yes, so we got num plus equals to, essentially we are adding this to this, and we essentially do this thing, calculation, where we take the first variable, 1 here, and put the x bar here. So for this x bar, we could just calculate very quickly. We got the 6 divided by 3, which is b2, which would be 2. So essentially, when we do 1 minus minus 2 into this particular thing, this is 8 plus 4, that would be 12. 12 divided by 3 equals 4. So that will be 3 minus 4, that would be minus 1. So this is 1 minus 2. Yeah, so minus 1 into minus 1 would be plus 1. Okay, that'll be a numerator. Then that be added to the number variable. So after certain calculations, I think we will be getting number and then. And we could just, sorry, this is not num. This is numerator, and then is denominator. So we could just be declaring the variable num divided by then. Okay, so that's about it. And we got the slope of the particular data, not this data. By the way, we could just plot this data by plt.plot x and y. I don't think this is a linear one. Okay, then plt.show, and this that's about it. And just save the thing here. And is that right? Okay, I could just do this, and we will get a very beautiful plot here. I think so, if everything is according to plan. It's supposed to be a plot here. Where's the plot? Where's the plot? Excuse me. Oh yeah, there's a plot. So we got the plot here with 3. Oh, okay, so we got the plot, but not the data points. And data points is something I think would help anyone here. So we could just add the data points. How? You could just do plt dot scatter x and y, x comma y, right? And just save the thing. Go back to the terminal, and there's a bit of problem here. List index out of range. Out of range. Why is that out of range? Why is this out of range? Or maybe I'm supposed to have 3 here. It is 3. Not sure. Let's see. Okay. We'll get this. So we got the data points as well. We got 1, 1, 3, 1, and we can see. Come here, little boy. So x coordinate is 1, y coordinate is 3, 2 coordinate, x coordinate is 2 here, and y coordinate is 4. A very weird data point. And x coordinate is 3, y coordinate is 5. So we got a linear regression model. And if you want a exponential data point, you could just leave this as it is and have multiple data points in this particular thing, which is sort of the square of the above number, and you'll just get like a linear upward graph like this, you know, like. And I could probably show you that quickly, just a minute. So this is what I meant. 1 to 10 and 1 to 10, but squared each number. So if we put that into the Python and run the code, we'll be getting a very beautiful regression model here. Not a regression, it's essentially exponential graph. It looks cute. Yes. We continue our thing, and I really don't, you know what, let's keep the data. Then we essentially have this particular thing. We have found the slope of the data, and we can also find the constant of the data. Okay, constant essentially means that what's the y-intercept? Okay, so y-intercept is nothing but y minus m dot x. Okay, and for this case we'll just keep y bar and x bar. Y bar, x bar is done. So after keeping y bar and x bar, we could just you know, we could print what we got. We could print what are the m and c value. M and c value, we could just print that out, and let's just print that out. Okay, f, so sorry, f string, then y equals m x plus c. Great. And we can save that. You can write the particular code this way: print equals f y, then this particular curly bracket m x plus c. Okay, that's pretty easy, I think so. And it would be much better if I just give a bit of space, because it really looks cluttered. Okay, if I just save that in there and do the Python thing, we'll be having whatever we require. And this is just the graph, but we're not caring about this thing. Just minimize that. We'll have this particular thing. Look at this. Y equals 9 blah 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 x plus negative 13 dot blah 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 blah. Okay, so we got the c value and m value. So this is the you know, equation for this particular data, right? So we just plotted that. Next, we could try to plot this data, this particular expression, along with the data which was originally given, right? So we could do that in the same graph. How? Actually, we could just move this graph to here, down, so every single calculation is done. And since we do know that it is Python uses an interpreter language, which just means that it reads from up to down. So if I keep this, if the data is kept here, so if the calculation is done later, the data doesn't really update later. Okay, so we can use plt dot plot. Wait a second, I need a bit of information there. I did a bit of cheating here, but we could be using the M and C and find out a new graph which is sort of you know, supporting the data here, okay, which fits in the data with the minimum loss function, which means that there's is essentially more accuracy whenever we plot this particular line. We are closer to these data points, okay? So we add this, first of all, we go to the import numpy as MP. We didn't add this line previously, so we do add it as MP. Then we go x underscore new equals to mp.linspace. Linspace is essentially a function which takes in the minimum and maximum values in terms of 100, I guess. Okay, so we take the minimum and maximum value of x variable, and we then take the y underscore new, this is a new variable, and multiply the previously calculated whatever this is, yeah, slope, and multiply with the new new variable of x and add the constant which we previously calculated as well. And if we write this particular data line where it is essentially plt plus dot plot the x what is this x coordinate and the y coordinate, right? So the x coordinate for this particular new graph is x underscore new, and the y coordinate of the new particular graph is y underscore new. And yes, that is about it. Now I just do I save the program first of all with Control S. Let's go, and we just go back in there, type this particular command Python linear regression practice.py. By the way, I did manually type this particular thing previously, and I just press these arrows here. If I press down an arrow, we just get an empty thing. If I press up an arrow, I get the previous function I wrote here, previous text I wrote here, so which is nothing but Python linear underscore regression underscore practice.py. And if I just click enter here, the thing runs, and we get a new line which is orange in color, and we get this particular line along with the data points. And the data point here we are getting actually is very exponential, okay, and we can have very scattered data points as well. We can have very scattered data points, so we could have very random data points like I'll just write it down very quickly. Yes, the data point that I might be having cannot be very perfect, so it could be like 1 2 3 4 4 9 5 11 6 20. There's no correlation between the data, but we have to find in the pattern which actually, you know, exists here, and we could have a line which is very accurate with the data that has been given to us. So if we actually have such a data, we could just plot them and calculate the best equation here, and it could sort of look like this. Yes, sort of looks like a linear graph, and which will be, you know, much more perfect. But this is just like a straight line, but we could go for a better line later in the next video. Yes, so which would sort of be like a linear, not linear, but like an exponential graph. Yeah, that's what we did in this video. I hope so it helped you in some sort of way, but it is helping me a lot because I am explaining this stuff. As you can see, I'm not really good at explaining, but the thing is, I will get better at it. I'm pretty sure because I'm working hard for it. Let's go. Brofist. Why am I brofisting? I'm not PewDiePie. Anyways, whatever. My dad's shouting a lot. What's the reason? I don't know. Anyways, bye.